Hello, Sir Jaehyun. Today, me and my group are going to present our computer vision final project called Mushroom Classifier. So the first thing that we're going to talk about is problem and motivation, continue with solution, methodology, result, demo, and lastly conclusion. Mushroom identification is dangerous because of many poisonous mushrooms look very similar to edible ones. Because of this, traditional foraging methods are unreliable and even experienced forager can make serious mistakes. Eating a poisonous mushroom can cause severe poisoning or even death. To solve this problem, we built an image-based system using deep learning. We use ResNet50 model to analyze mushroom photos. Each species is then labeled as edible or poisonous, giving user a clear safety result. To make the system easier to understand and verify, we use explainable AI with GradCAM heat maps. The heat map shows which part of the mushroom image the model focuses on, such as the cap or gills, when making its decision. Finally, the system is provided as a user-friendly web application. User can upload mushroom image and receive a clear result along with visual explanation. This system is designed to help user avoid dangerous mistakes and reduce the risk of mushroom poisoning.
Right. Thank you, Brian. Now I, Kenneth Jonas Fang, will guide us to the next part, which is the methodology. We are using the edible and poisonous fungi dataset from the Kaggle, around 3,400 images, which contained 4 categories: edible mushroom sporocarp, edible sporocarp, poisonous mushroom sporocarp, and poisonous sporocarp. For this case, we only need 2 classes of poisonous and edible, regardless of it being a mushroom specifically or not, so we map them together. For the library, we utilized PyTorch Vision, specifically PyTorch Lightning library for development. We used a pre-trained model known as ResNet50, or also known as residual network, with depth of 50 for the CNN analysis, resulting in a model with around 23 million parameters and 20 target epochs, with patience of 7 epochs to stop training early if no loss improvement. For the patient's amount of epochs, as can be seen here, it stops at around 15 epochs because of no progress after around. The resulting model has an accuracy of around 87%. Critically, the model has 90% recall in identifying poisonous fungi in comparison to 77% for the edible ones, which is better since it is more important to know about poisonous ones than edible ones. The heat map made using GradCAM shows that the model really emphasizes on analyzing the branch-like part or the gill of the fungi to determine the toxicity of the plant. This result validates that the model is looking at the right things and not affected by the background or other features of the image like a trunk or parts of other plants. For this model to be fully utilized by the general public, we published a Hugging Face demonstration website where users can simply upload an image of a fungi to get an estimate of how toxic it is. As examples, I have a pair of images of fungi. First is an example of a poisonous fungi, Sclerotis, from a simple internet search of toxic fungi. The result is, of course, detected as toxic. Another one is a well-known edible Japanese mushroom, also from a simple internet search. If we test here, it results in edible. Next, for testing for other images, especially those which are not fungi at all, for example, is a picture of an area near the lobby of the Alam Sutra campus. This result shows something random, but we can see here that it is not confident at all about the toxicity, meaning it does work and doesn't just confidently hallucinate when given other images, not fungi. Another image is from a sidewalk near campus. And it also shows that it is also not sure. It has low confidence. As conclusion, we have successfully created, trained, and tested a Spore Corp toxicity classifier in production using a well-known pre-trained model with a decent accuracy, and also shows clearly how the model identifies and thinks to classify, which potentially also helps us knowing the difference between potentially toxic and edible fungi from the heat map records. We hope to be able to use this with more and more training data and better performance in the future. Thank you for watching.